Assembly constraints were recently added to Fusion to complement the joints. And let's look at some uh, comparisons between the motion joints and the equivalent assembly constraints. First of all, if we have an object in space, we can move that object in the translate along the Z, we can translate along the Y, or we can translate along the X. We can also rotate around the X, Y, or Z. So we have 6 degrees of freedom of an object in space if we pick that object up in our hand. So when we're assembling a mechanism, we're looking how to constrain those degrees of freedom to get the appropriate motion. And so let's say that we want a rigid joint. So I could do a constraint, and I could constraint, the equivalent constraint would be to do the YZ to the YZ, and then I'll add the second constraint. I'll do the XY to the XY, and then the third constraint, I would do the XZ to the XZ. And now if I try to move this, it doesn't move. It is constrained or rigid. Let's undo that and look at the next one. And I want to make sure that I don't have any constraints over here. So the next one is a revolute. Remember, we have 3 revolution degrees of freedom. We'll do the Z, the Y, and the X are the same. Maybe we'll do more than one. All right, so if I select the X axis, or I could select this cylinder, but let's assume that we don't even have any geometry here, and we'll just select or maybe the Z axis. I'll select that Z axis, and then I'll select this Z axis, and now I'm doing a revolute, so I need one more constraint. A revolute has 1 degree of freedom, revolve. So I'll add one more constraint, and I'll do the XY to the XY, and I'll say OK to that. And now if I rotate this, we see that we have 1 degree of freedom, revolution around the Z. We could do this a revolution around the X, or we could do a revolution around the Y. I think you get the idea on that. So I'm going to undo that one, and we'll go to the next one. So the next one is a slider, and so slider has a 1 degree of freedom or translation. So I'm going to do a constraint, and I'm going to select the XY to the XY plane, and then I'm going to do another constraint. I'll select the Y to the Y. Let's do it over here so that we can see that we can pick the actual axis rather than the geometry. I could have picked the geometry, and I'll say OK to that. And so now we see that that has one translation along that particular axis. We could put it along this axis, or we could define a new axis for that direction of translation. Let's undo that one, or I'll just delete it. And let's do the next one, the cylindrical. So cylindrical has 2 degrees of freedom. It can revolve and it can translate. So that'll be similar to the slider, except the slider didn't revolve, it only translated. I'll do a constraint. I'll do the y-axis to the y-axis again. Okay, and then I'm going to do so this one can revolve around that y-axis, and we'll say okay to that. Actually, it's 2 degrees of freedom, so it can translate. See if I got okay. So it can translate along that axis, and it can rotate around that axis. Okay, so the cylindrical, 2 degrees of freedom, 1 rotational degree of freedom, and 1 translational degree of freedom. And of course, we could do that around the X, or we could do it around a Z or a user-defined axis to get the equivalent constraint to this cylindrical. Pin slot would be, I'd have to think about that. I'm not sure there's an exact equivalent, direct equivalent. Doing the pin slot, perhaps adding a tangent, but we'll skip over that pin slot. And we'll do the planar. So I'm going to delete this. And so I'll do planar. And I'm going to select the XY to the XY, or any 2 planes. And now this can move anywhere on that plane. Now in 3D it might look confusing. See, it looks like I'm moving that up above that plane, but if I look at it from a side view, we see that it can only translate on that plane. It can't move up and down, can't move off of that plane. All right, so you got to be a little bit careful on some of these constraints or joints, that you have the motion that you think you have, because it can fool you on that. And then the ball joint, so let's delete that one. And I'll do a constraint, and I'll select the origin of the component and the origin of the assembly in this case. And so now we have 3 rotational degrees of freedom, no translational degrees of freedom. So that's a simple example of some equivalence between some of the assembly joints and equivalent set of constraints that would achieve that same degrees of freedom.